Hi everybody and welcome. Today we're going to be talking about the quadratic formula and solving for x-intercepts when those numbers aren't nice, when they work out to be really messy decimals and big square roots. So your goal after watching this video will be able to solve quadratic equations for their x-intercepts using the quadratic formula. So looking at a real-life example of when this actually came into play, baseball pitcher Randy Johnson, a Hall of Famer, I think it was almost probably 15, 20 years ago now, was throwing a pitch, and a bird got in the way. And that bird, unfortunately, is no longer with us. And it was this whole thing because initially people were laughing, but then they started feeling bad for the bird. And this is a picture of him throwing that pitch and what was left of the bird after that. And why this became a big deal was because PETA actually got involved, and they tried to, I guess, more or less see if Randy Johnson was guilty of animal cruelty for throwing a baseball at a bird. Now, he was ultimately innocent. He wasn't trying to hit the bird. He was just throwing a pitch, and the bird was in the wrong place at the wrong time. But this is actually an example of quadratic motion, and they needed to model this to actually see where did the ball intersect with the bird. So he started throwing it way up here. He releases the ball, and it starts its path down to the catcher's mitt. And you'll notice here that that's actually an example of a parabola. So that's quadratic motion. So if you were to trace this, now this doesn't exist, this part of it, but you would see, again, a nice shape like that. So we can actually solve for this point of intersection right here, again, using the quadratic formula. And that's an example of it. So we would take the equation of the graph of Randy Johnson's ball, and we would set it equal to the height here of where it intersects with the bird. And then using that, we'd be able to find the exact point on the XY axis here of where this bird actually was hit. And I'll give you a hint, it's probably not going to be a nice, clean, even number. It's going to be a decimal, going to be some big stuff to deal with. So that's why we need the quadratic formula. This is an actual, funny, kind of weird, but real-life example of using the quadratic formula. So that's our definition for today, quadratic formula. And for this, it's just a way to solve for the x-intercepts of a quadratic function in standard form. So if you're looking at something like y equals ax squared plus bx plus c, that is your standard form. And once you have it like this, you can solve for what is x equal. Instead of having to factor and draw out a box and all that stuff, we can just use negative b plus or minus the square root of b squared minus 4ac all over 2a. And where are we getting a, b, and c from? Well, there's a. I did the wrong thing there. There is A, there's B, and there's C. So you'd plug those all in one at a time, then you'd be able to solve for that answer. Let's go over an example of using this. You'll have an opportunity to practice with a few more of these, and we'll go from there. So your first job with these, for those quality and procedures points, is identify A, B, and C. Well, A we have as 1, B is -4, and C is -2. Be careful here. It's not just 4. It's -4, it's not just 2, it's -2. Now we can go through and plug into the quadratic formula. And again, making sure we are plugging in the right numbers in the right spots. So carefully matching these up. Everywhere that we see a B, we're going to plug in a -4. Everywhere that we see an A, we're going to plug in a 1, and everywhere that there is a C, we'll plug in a -2. So now that we've done that, we can start evaluating using Pemdas. Things like double negatives, those become a positive, so we'll have +4 on the outside, plus or minus the square root. -4 squared is -4 times -4, that's just +16. And then we can punch all these into the calculator at once. -4 times 1 times -2. Well, 2 negatives and 1 positive get us a +8 from 4 times 2. So that came from right there. And then last on the bottom, 2 times 1. So again, continuing to solve, 4 plus or minus the root of 24 all over 2. And that would almost be our final answer. We just have to remember, again, when we see something like the root of 24, we do need to split this out into its parts. So we'll see 6 and 4. And again, we can split that 4 into 2 and 2. And that's our pair that we can take out. So we'll have 2 root 6. So what this leaves us with is 4 plus or minus 2 root 6. And each of those is over 2. Or we can simplify that to 2 plus or minus the square root of 6. So a couple things to recap here. The emphasis from today's lesson is identifying A, B, and C and plugging those in. If you're able to do that, you're at least at that 70% passing level. The second step is getting up to a higher level of percentage correct, is evaluating using Pemdas and getting yourself to this point down here. And again, if you want to go for that A range, we have to take that and simplify it even more, break down that square root. But again, the big point of emphasis from today is let's at least identify and plug in A, B, and C. If you're evaluating them, you're doing great. And if you're simplifying them, you are amazing. So that's what we're looking for today. That's the big skill. Again, left some extra time here for practice and a few examples. Really, really important just to get the repetition in for using the quadratic formula. Before I sign off here, let's do the setup together for this next one. That way we have a place to start plugging in and evaluating. So those are our 3 numbers. We have A, we have B, we have C. And right now it's your job to be labeling negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So now, again, your turn. Plug those in, see if you can evaluate and see how far you are able to simplify. All right, everybody, bit of a more challenging lesson here today in terms of the actual evaluation, so definitely reach out, email, message, any of those things, book an appointment. Mrs. Denowitz and I are here to help. Again, appreciate you tuning in, and I will see you in team.